Okay, so now today we are going with the very important chapter. Okay, and probably the last chapter of your final year IMA. That is the very important, but the high performance liquid chromatography. So basically, now moving towards the chromatography, we are very much acquainted with the concepts of the chromatography as well as the retention time, what is retention time, the equations, dead volume, and thereafter HETP, and all these things we are very much acquainted. Okay. Thereafter, we have seen the column chromatography also, ion exchange chromatography, okay, gel chromatography. So that has helped us. Okay. So now we are moving to one of the most important parts, and this question is the examiner's favorite question, always has been asked in the exams. From this chapter, the question of 10 marks, 5 marks is always there. So we can't rule out the possibility of not coming from this chapter. Okay, so HPLC infers for high performance liquid chromatography, and here also what we do the same thing. That is, we separate the component of mixture. Okay, but only the difference is that in the paper chromatography we don't apply pressure, we apply the surface tension. The same thing applies with the thin layer chromatography. Here we apply the high pressure and hence called as the HPLC. Okay, and these are the mixture of the components A, B, C. Okay, and this is the most widely used industrial technique. Research developmental centers utilize the techniques. Quality control laboratories always prefer this HPLC techniques. Food testing laboratories and educational institutions are always mostly binded to show at least the functioning of the HPLC. Okay. Thereafter, it is basically a liquid chromatography. Obviously, it is a liquid chromatography, and the mobile phase is the liquid and mechanically pumped, and it is mechanically pumped through which? Through the column, and that contains a stationary phase. So, what is the mobile phase? Liquid, and liquid is, please don't talk. I request all of you to mute yourselves. Yes, please. I request everyone to cooperate in this case. Okay. So if unmute happens, so take a note of that. That can be muted. Okay. So kindly do that. So basically it is a liquid chromatography. Here the mobile phase is liquid, and how it is done? Here we apply the high pressure. So high pressure on what? So mechanical pump is applied, and through the mechanical pump, the liquid phase has been passed through the column. And where it goes? It goes through the stationary phase. So these things are there. Okay. Now what are the advantages of the HPLC? It is a highly efficient technique. Okay, the stationary phase used can be used again and again, irrespective of the other techniques. You have to change the stationary phase. No, the thing only you have to keep in mind that after one run in the HPLC, you have to do the purging. Now, what is purging? Purging is the washing of the whole system of the HPLC. Okay, if you are not doing purging, okay, so purging, if you are not performing the purging process, that means you are not interested in getting the accurate, precise results. Okay, and you are not the strong believer of the randomness, robustness of the results, and you are not you have not complied with the that International Council for ICH, Council for Harmonization Processes. Okay, so you have bypassed all the processes. So one thing that always is a concern, matter of concern in HPLC is purging. Okay, once the first run happens, okay, do the purging. Before the first run, you always go and check the baseline. Okay, before the run, you have to check the baseline. If the baseline is stable, thereafter you can start the run. Post run, you have to do the purging. Okay. Purging is nothing but the washing of the system. And for washing of the system, you need not to keep the mug with the distilled water and you have to wash the HPLC. That's not the case. Here you have to do only the one thing. You have to just push the button of purging. Okay, the purging of the internal system happens automatically. Okay, so whenever there is a live instrument, okay, I am of the opinion that the purging should be done compulsorily after every step. That note should be pasted there so that the researcher, the chemical analyst who is performing work on the HPLC there are very less chances that he or she misses the things. Okay, so what happens thereafter? You apply the high pressure. Okay, so and thereafter the what are the other advantages? Time consuming technique is very less. Okay, so it's a very efficient technique. Thereafter small size stationary phase can be used. Now the types of the HPLC. Okay, so the normal phase HPLC, reverse phase HPLC. These are the two major types. Okay, so if we talk about the normal phase HPLC, so they are also known as the normal phase or the absorption chromatography. Okay, and the method separates the analytes based upon their polarity. So in normal phase HPLC, polarity is the check. Polarity is the check in which separates the two phases. Okay, now if it is having the polar stationary phase and the non-polar mobile phase. Okay, so you have to keep the condition in mind that in normal phase chromatography, the stationary phase should be polar and the mobile phase should be non-polar in nature. Okay, are you getting what I am saying? The stationary phase should be polar and mobile phase should be non-polar. Okay, this question can come in your MCQ. In the normal phase HPLC chromatography, the stationary phase is mobile, polar is the stationary phase is mobile and the mobile phase is non-polar in nature. Okay, now, what is the composition of the stationary? We are talking about the stationary phase, stationary phase. So, stationary phase is having the composition of the silica and the mobile phase can be made up of hexane, methylene, chlorides, chloroform, diethyl ethers. Okay. Now, what is the utilization of this technique? This can be used for the water sensitive compounds. That means the compounds or the samples which are prone to water. That means so non-aqueous compounds can be easily done through this normal phase chromatography. Geometric isomers can also be separated by this process. Are you getting what I am saying? Yes. Are you getting what I am saying? Please tell me. Hello? Please tell me. Hello.
Yes, sir.
Now the reverse phase chromatography. The stationary phase is non-polar, hydrophobic in nature, while the mobile phase is aqueous, moderate polar. Now the second type is the reverse phase chromatography. So in the HPLC, the stationary phase is non-polar. Non-polar means hydrophobic in nature, while the mobile phase is aqueous, moderate polar. Aqueous, moderate, polar. Okay. So how it works? It works on the principle of hydrophobic interaction. Okay. What it uses? It uses non-polar, polar ionizable and ionic molecules. Okay. So this is the reverse phase chromatography. I repeat. What happens with the stationary phase here? The stationary phase is hydrophobic, non-polar in nature, while the mobile phase is aqueous, moderate, polar. Okay, and what is the principle by which this reverse phase HPLC works? It works on the hydrophobic interaction. Okay, now what are the uses of this reverse phase HPLC? So it is used for non-polar, polar ionizable and ionic molecules. Now the third phase is the size exclusion HPLC. Please don't talk. I request all of you. So size exclusion HPLC. So that is also known as the gel permeation chromatography and also the gel filtration chromatography. Now what happens in this technique? So molecules in the solutions are what done? They are separated. Okay. And the separation is done on the basis of their sizes and in some cases on the basis of their molecular weight. Okay. This happens in the size exclusion HPLC. Okay, are you getting what I am saying? So all these things are there. Now, larger molecules, they get washed rapidly through the column. Smaller molecules, what they do, they penetrate the porous packing particles and elute later. Okay, it is also helpful in determining the tertiary quaternary structures of proteins and amino acids. Okay, it is also used to determine the molecular weight of polysaccharides. You can see the diagram here only. The polysaccharides can be easily separated by this use. Okay, proteins, amino acids, very important. Again, molecular weight assessment of the molecular weight of the polysaccharides. Again, the one of the best methods. Which method? Size exclusion method. What happens in the size exclusion method? The molecules are separated on their basis on the base of their sizes and the molecular weight. Okay, the what happens? The larger molecules are flushed away faster through the column. Smaller molecule penetrate through the packing particles and elute later. Okay, what are the uses? It is used for determining the quaternary and the tertiary proteins and the amino acids. Okay, and it is also used for determining the molecular weights of the polysaccharides. Any doubt till date? Any questions? Please let me know. I am all yours. Please tell me. We are all here for a healthy interaction. Okay. Can we proceed? If you want, I'll repeat. If you want, I'll proceed. Please let me know. Be interactive, beta. Please tell me, can I proceed? Hello. I had given you the rights.
Yes, sir.
Yeah. I had given you the rights to talk. Okay. Rename yourselves. Okay. Ion exchange HPLC. So this is also a type of chromatography and retention is based upon what? Attraction between solute ions and the charged sites that are bound to the stationary phase. What we are talking about? We are talking about the ion exchange HPLC. So what happens in this type of the chromatography? The retention is based upon what? Attraction between solute ions and the charged sites bound to the stationary phase. Okay, some of the charged ions are excluded and why they are used? They are used in the purifying water. Thereafter, bioaffinity HPLC. So this in this chromatography, the separation is based upon the reversible interaction of the proteins with the ligand. Okay, so bioaffinity HPLC. So in this chromatography, the separation is based on reversible interaction of the proteins with the ligands. Ligands are basically the sites. Okay, proteins are the samples. Agree? Okay. Hello. Can we proceed? Yes bete, please tell me.
Yes, sir. Yes, sir.
Yes. So now the principle of HPLC. So now the principle of HPLC, it is based upon the two type of the chromatography. Okay. So the HPLC follows the two mechanisms. First is the adsorption chromatography as well as the partition chromatography. And the what it depends upon the nature of the stationary phase. Okay. And what is the expectation of the principle of the HPLC? The stationary phase should be solid, and the principle based on the adsorption chromatography. Okay, the stationary phase should be solid, principle should be based upon the adsorption chromatography. And if by chance the stationary phase is liquid, the principle should be based upon the partition chromatography. Agree? Hello. Okay.
Yes, sir.
The theory, it is very similar to the normal phase chromatography. We have seen it. Now the instrumentation part, very, very important. Okay. So you can see this, very important. This is sample injector. Okay. Now this is the column. This is the detector. This is the data collection device. Okay. Here the HPLC solvent is there. From this HPLC solvent, it comes to the pump. Here we inject the sample. Okay. It goes to the column. Thereafter, this is the detector and this is the recorder. Okay. The waste goes here. So this is the recorder, is the data collection device. Okay. Thereafter, the reservoir solvents are mobile phase, pump, sample injector. Okay. Thereafter, column, detector, data collector device. I repeat. First is the reservoir solvent, mobile phase. What is this reservoir solvent? This is the mobile phase. Okay. Thereafter, the pump. Okay. Thereafter, the sample injector. Okay. Thereafter, the column. This is the column. Okay. Thereafter, the detectors. Different type of the detectors are there. Thereafter, the last thing is the recorder. Recorder is called as the data collection center and the west. Okay. Now the mobile phase. Okay. So what is the composition of the mobile phase? Mobile phase is usually organic in nature or aqueous or mixture of both. Okay. So the mobile phase is placed in the bottle of the glass. Okay. Now what are the characteristics of the mobile phase? So it should be very pure. The viscosity should be low. Okay. Price should be very low. Compatible with the detector. Detector compatibility should be checked prior assembling the instrumentation. Okay. Thereafter, the solubility of the sample should be checked. Chemically inertness should be checked. Mobile phase, solvent A, solvent B. Solvent A, water. Solvent B, organic solvent. So it is miscible with water such as the acetone, nitriles, menthols, isopropanols. Okay, are you getting what I am saying? So these are the things. I repeat, the mobile phases the mobile phase is usually organic or aqueous or the mixture of both. Mobile phase is placed in the bottle of the glass. Now, what are the characteristics, expected characteristics or the cardinal factors which govern the mobile phase? So it should be very pure. It should have the low viscosity. The price should be low. Compatible with the detector, it should be done before assembling the device. Solubility of the sample should be checked. Chemically inert, are they? Please check it. Thereafter, the pumps are used obviously for forcing. Forcing for of what? Forcing of the mobile phase. Forcing of the mobile phase from where? Through the column. Okay. And the pump should be capable of delivering the high pressure of 5000 psi's. Okay. The flow rate range should be around 0.1 to 10 ml per minute These 2 points to be considered very important, because that can be asked in your exam. What is expected pressure in the pump? 5000 psi. What is the flow rate? 0.1 to 10 ml per minute. So that can be asked. The pump should be capable of delivering the high volume of the solvent. Okay. The first thing, now the type of the pumps. So types of the pumps में पहला कौन सा आएगा? Reciprocating pump. Second आएगा syringe displacement pump. Thereafter pneumatic pump. Pneumatic pump is also known as the constant pressure pump. Thereafter the constant flow pumps. Okay, all these things are there. Now the sample injector. The injector can be a single device, okay, or an automated injection system. Injectors for a HPLC should be providing an injection of liquid sample within the range. What is the range? 0.1 to 100 ml of the volume with high pressure up to 4000 psi's. Sample injectors can be a simple sample injector or a automated injection system, and it should provide the injections of the liquid sample within the range of what? It's around 0.1 to 100 ml of the volume with high pressure about 4000 psi's. Now the columns, let's see what are the expected things of the column. So the composition of the column, the column should be made up of the stainless steel. Okay, and what is the length expected? Internal diameter expected. Okay, so the length is expected to be around 50 to 300 mm, and the internal diameter is expected to be around 2 to 5 mm. Okay, thereafter it should be filled with the stationary phase. Particle size should be around 3 to 10 micrometers. Okay, so now the column internal diameter should be less than about 2 mm in diameter, and it should also be called as the microbore. The internal diameter should also be called as the microbore. So these are the expectation of the column. I repeat, the columns are usually made up of what? Stationary stainless steel. Okay, MCQ number 1 can be asked. What is the length of the column? It should be around 50 to 300 mm of the length of the column. What is the internal diameter expected? It should be around 2 to 5 ml. 2 to 5 mm. Okay, so this can also be asked in your MCQs. Okay, and thereafter it should be commonly filled with what? Stationary phase. Particle size should be around 3 to 10 micrometer. And if the column internal diameter is less than 2 mm, then it is called as the microbore. So this question can also be asked, what is